So I have been given this opportunity to give you maybe one of the most tangible talk of this conference, hence the name, Concrete Reality of the Cloud. So I'm from the infrastructure department. So we are in charge of deploying and scaling all the network and the data centers where the data workloads are actually hosted in our infrastructure. So that's me. So what is this talk about? I joined in 2011 at a time where Crideo had something like 200 servers. And I have been given the tough mission at this time to work on the issue the company was facing, meaning that in 2011, Crideo was collecting more data than it was able to store and compute. So everything was made around SQL servers, scheduled tasks, and Samba file shares on Windows servers. So all the logs were collected through FTP, copied by Samba protocols, and at the end, so Justin mentioned everything that was done for BI in SQL Server. We had one big database. I remember it was named BigStatDB. It was 40 terabytes and not able to scale anymore just because we reached the daisy chaining capacity of the servers, meaning that we were daisy chaining the drive enclosures, and we reached the limits where it could not fit anymore in the cabinets, and I guess the chassis was not able to cope with one more direct attachment chassis beyond. So this is how Hadoop began at Crideo in 2011. As Justin said, at that time, it was pretty immature, so it was just a matter of testing and prototyping, and I have been given the chance to work on that. So, beside Hadoop, we have the remaining infrastructure. So the growth of the infrastructure was something like 20 times in 7 years. So I told you in early 2011 we had 200 servers, and today we have something like 25,000. And the share of voice of the Hadoop nodes, not including the whole Hadoop ecosystem, because Hadoop by itself is just providing a distributed compute and distributed storage, but you have a whole bunch of servers around Hadoop because Hadoop alone is almost not useless, but it won't provide you all the features and all what you could expect from your data. So the data nodes, the green bars, accounts for something like 20 or 25% of the total amount of servers. So that's the growth of the infrastructure, or we had to scale that by 25 times. And the requirements we got from the company is just go big or go home. That's the traffic increase we had to face on the global infrastructure. And most of the data we put in Hadoop is coming from that traffic. So that's the relative growth of the intake traffic on a daily basis. So as you can see, it's up to 900% over the last 3 years only. And all the data we collect are coming from the more than 18,000 customers, for the 1.4 billion users, which actually translate into 3.6 billion devices, and we display 4 billion banners a day. So it's really important when you manage your own infrastructure to have the requirements. Here is the requirement we add, just bigger and bigger every day. And what is interesting when talking about Hadoop is that we had to learn a lot what could become a large-scale infrastructure just by managing a Hadoop cluster. It's only 20 or 25% of the total infrastructure, but we had to face many issues. We made a lot of mistakes by just managing the Hadoop clusters. So everything began in 2011. So I remember at that time the CDO and founder of Crideo just told me, okay, pick 1 million and try to do something with Hadoop. No one knew about Hadoop. Only one book was available at that time. It was the one from O'Reilly. And we made some tests. I have been given something like a few servers that were laying in the basement, and we made a prototype, and we came back with a full design for 160 servers and 10 cabinets, and that was 1 million. So I came with the quote to the CDO. He said, it's expensive. I said, no, it's 1 million. You say, pick 1 million. I picked 1 million. I said, yeah, but it's expensive. Try with half of that before. So we really started with 60 servers. And so 60 servers was something like 700 terabytes. Since it was new, we had no data inside, so we had to work also on migrating the workloads and put the data in that new cluster. And it became very quickly too short. We were lacking the space, so rapidly we went to spend the million that we expected at the beginning, but it was not enough. We had many issues, and we just discovered as well that around Hadoop, you need a lot of people to manage that. So within 1 year, we were creating a dedicated team, the HPC team, working on that Hadoop infrastructure, just because it was too much work for one ops team, as we were used to manage at that time. So we faced many roadblocks on the network side as well, on the power side as well. So in 2013, we said, okay, let's invest more in that technology. So in 2011, we didn't know anything about Hadoop. We didn't know if it was able to solve the issues we had. Remember, we were collecting more data than we were able to store and compute. So in 2013, we decided to invest a lot more in that infrastructure. So confident with the new network design we made at that time, because we have been working closely with one of our network vendor at that time, we decided to set up a new data center where the workload would be mixed between Hadoop and the real-time production. That was a huge mistake, actually. Never trust your vendor, just because when you've got an Hadoop cluster within your infrastructure, you get a lot of east-west traffic, which is not the same traffic you could expect from a traditional web architecture where everything is north to south. So all the network traffic for Hadoop was eating the space for everything else. So we were breaking the production traffic because of Hadoop. So we had to change rapidly what we've done. So we did set up a dedicated room in the same Amsterdam data center. So it was 0.5 megawatt, ready to grow up to 1,200 servers roughly, and that was 50 petabytes. And once we've done that, we discovered many other issues. So once again, never trust your vendor. So we were, as per the spec sheet, we were suggested to put 21 servers per cabinet. And a few months later, we had to move the servers because 16 was only what we could afford because of the power requirement we had in the cabinets. So we still had to grow. You have to keep in mind that everything we've done at this time was done live, meaning that the production was not supposed to turn off. So the Hadoop cluster was really used by the business. So for all the issues you were facing, you were accountable for the sanity of the business. So in 2015, convinced that Hadoop was definitely the technology we required, we decided to invest a shit tons of money on a new cluster with 1 megawatt of power in the data center, able to grow up to 2 megawatts and up to 6,000 servers. So this is what we have done, and this is really the period of the maturity. Working on that project, we had to redefine everything we did from the beginning. So for the power design, we went to 3 phases, power feeds. For the network design, we went to leaf and spine, what would become 1 year after the RFC 17938, how to use BGP routing in large-scale data center. And we were more confident with the way we define everything on that. And this year, in 2018, so we know that we will need more and more Hadoop nodes, so we are opening a second site. So we will have to learn how to schedule jobs across 2 clusters that are remotely set up, one in Paris, one in Amsterdam. And we are ready to grow up to 15,000 servers, and we are reaching the exabyte scale. Amazing. So what we have done in these 2 last projects, we define our own standards. So I told you we had to find a way to solve the network issue, because network was really an issue. So by using the Clow Fabric, the leaf and spine network, we were able to provide a non-blocking network, meaning that each time we give 10 gig access to a server, we can have 10 gigs point-to-point everywhere on the network. All the nodes are at the same distance, the same number of hops between each other. And we solved many things. We have to solve also the connectivity issue, because once you got a large Hadoop cluster, you need to feed him. We are collecting several hundreds of terabytes a day. That's a lot of connectivity. So for example, we have dedicated links all over the world, up to 3 terabits per second of bandwidth, just to feed the Hadoop clusters. And just to synchronize the 2 Hadoop clusters in Europe, we have 400 gigs of bandwidth between Paris and Amsterdam. So you define your standard on the way you design the LAN, the way you connect the network to the rest of the world. You also have to carefully plan and design the physical space, the room layout with the data centers. So we rent some space in a co-location facility, and you have to define in advance how you will use the space, because that's the way you will deploy the cabling. Just imagine that for that kind of room of 1 megawatt, it's up to 36 kilometers of fibers that you have to deploy. So it's not when you need it that you will wonder where the cables should go. Also, you have to care about the redundancy, meaning that you can cross in the room with an axe and break one pass wherever you want. It's supposed to be still working at the end. So that's the requirement for the cabling. The huge benefits of the new network design is that you can have a programmatic approach, either for the configuration, the provisioning, or for the cabling. By having 36 kilometers of fibers to deploy and a few thousands of interfaces, you don't want to draw the patterns by hand. So having that done a programmatic way is really time-saving. And it's all about outsourcing the physical duty. We are working with engineers. There is no value in having your engineers carrying tons of metal or laying up kilometers of fibers. All the more if you know the network engineers. They are not the kind of guys that will love you for that kind of work. And you might not love what they will deliver. So this is what we were used to do when we were asking the network engineers to do the cabling job. But at the end, it was not their primary job. So by working with proper contractors and dedicated team, first you will end up with a more operable cabling. Plus, investing in your cabling is key in that kind of investment. So when you set up a 1 megawatt room with such design, you have to consider it's up to 1 million of setup fees, including the cabling, just by investing properly on that part. Having the cables handled as assets, you will be able to upgrade your network without touching the cabling. Meaning that this cabling is ready to grow from 10 gig access to 100 or 200 gig access. You will have to change the equipment, obviously, but you can invest on your cabling for the long time. So the good news when you outsource the work is you have to ask your engineers to provide documentation. that's an intelligible version of the cabling matrix. So I told you the cabling is done in a programmatic way that is producing that kind of matrix that you can give to your contractors, just to let them know where are the A, Z points of the cables. You provide documentation as well on the way they have to rack and stack the servers. So you don't want any surprise at the end, so you have to carefully describe what you expect to have it done. Operating at scale and deploying at scale means if you want to apply software engineering methods to have a CI/CD for bare metal, but instead of a software factory, you will have a data center factory. So on top of the graph, you've got the engineers working on your infrastructure, plus the bunch of tools for automation, asset management, IP management, and the provisioning script that are used here at Criteo. So it's a mix of Ansible to provision the network, plus Chef once the servers are live, and we have in-house tools like Raguru, the in-house asset manager we use. Then another issue is how you physically handle the job. So you rent a colocation space in a data center that is supposed to host thousands of servers, and then you discover that when you buy a few hundreds of them, the loading dock is full. They cannot even manage the trashes, because once you unpack the server, you've got the box on one side and the servers on the other side. And we created a traffic jam in Manhattan just because we were delivering 700 servers. So it's a few trucks delivering the servers. And after 2 or 3 trucks, they say, no more. We have no more space. Please go back. The issue when you do that in Manhattan, it creates a huge traffic jam. And you've got a few millions of assets on the sidewalk. Hopefully it was not raining, but that's the kind of issue you have to manage. Plus, you can kill your people. Just asking someone to rack and stack a few thousand servers is just harassing, it's exhausting. Just imagine one Hadoop server is something like 35 kilograms. So when you deploy 1,000 of them, it's 35 tons he has to carry. So for the CD, for the continuous deployment, we went to the rolling rack solution. So we have the cabinets prepared in advance in a warehouse, and we put them in a coffin and in a truck, and we roll them to the data center. And that's really interesting as well for a capacity planning reason. By providing batch of servers by hundreds or by thousands, you are not optimizing the life cycle of your assets. If I deploy 1,000 servers 6 months in advance, it's 20% of the lifetime wasted. So you want to deploy the servers in a just-in-time manner. All the more because even on Hadoop, so Hadoop is asynchronous workload for us, there is a huge seasonality effect. So that's the HDFS usage the week of Thanksgiving. So you can have the need for 50% more storage just in 1 week. So if you are not good at capacity planning, you will break and you won't have time to provide that amount of servers in 1 week. The same for the bandwidth, so that's the IP transit vision of the Thanksgiving week. So just in 1 day, you grow up by 30% your outgoing traffic. That's huge. So as a conclusion, we have learned a lot by growing the Hadoop infrastructure, and it helped us to forecast what could become the real-time traffic at scale just by scaling the network, for example. The way we manage and the way we design the network was a huge learning just because of Hadoop. All the east-west traffic you have on an Hadoop cluster is the way the usual web traffic is evolving today in a large infrastructure. We had to upskill all the engineers, all the ops people using the DevOps methods and moving on a more SRE way of work. Also, we learned that you should not trust your vendors. You have to define your own standards and find the vendors meeting the standards. Don't trust any features that will be really expensive, not scalable, or not reliable enough to scale your infrastructure. We were really happy to mix and match a lot of different vendors on the network stack. In the new network design, for example, we are able to mix and to replace one Arista switch with one Juniper switch just because we made the work in advance and just because our own standard is relying on IP and BGP, that's it. So we got rid of all the proprietary vendor features that we are used to have in the network and that were proved to not be working a lot. So that's the current footprint we have today. And once again, Hadoop is not the biggest part of the infrastructure. It's something like 20 to 25% of the total amount of servers, but that's really the way we learn a lot. We learn from the users. They are like gas. The more space you give them, the more they will eat. So they are used to fill the whole container space you give them. That's really challenging. In the future, we hope to integrate GPUs or TPUs or other kind of hardware that will be challenging the stack. Just imagine the issues you had on the network by using traditional commodity servers. By adding a GPUs, you don't want to have the network or the disk IOs become a new bottleneck. By processing a large amount of data on GPUs, you need to ensure that the network will not be the roadblock for your workload. The network is really used like a bus in a data infrastructure. So you have to be ready for change and to be agile enough to upgrade once your user requests it. And ultimately, once your DC factory is ready, you just click on a button and you have your data center deploying automatically. But not there yet. Thank you.